Today we are talking about Kirchhoff's laws. An example is this. So if you want to use Kirchhoff's law, you need a current and a loop. So let's try that. Call this I1, I2, I1, I2, I3, then you have because I1, I2, I3 are all leaving this junction. Therefore, their sum must be 0. This is one equation. So I have 3 unknowns, I1, I2, I3. I need 3 equations to solve for 3 unknowns. This is one equation. I need 2 more. 2 more is one loop here, one loop here. And the Kirchhoff's law tells us you write the drop around the loop, and it should equal to 0. So you have delta drop, delta V. If you add everything there, V is the drop. The drop here, this is a rise. So IR minus 3.3 minus I times 2000, and this is I2, so this is plus minus, so this is rise minus I2 4700, and so on and so forth. So you write second equation, third equation. But because this circuit is very special, the numbers, the values given are quite special. So we don't need Kirchhoff's law. How do we do that? First step, combine the 1000 and 2000 to become 3000. Combine this 1000 and 2000 to become 3000. So I redraw this circuit. .3 volt, 3.3 volt, 1000 plus 2000 is 3000. 1000 plus 2000 is 3000. This remains 4700. This circuit becomes this circuit. By the way, This question was given to me by my student who is a first-year student at a university in Ontario. I don't want to mention which university, but this is the assignment. Now, look, because the values given are so special, here, 3,000, battery voltage 3.3, this branch are all in parallel. Because they are all in parallel, I can redraw this. I draw this branch and this branch closer together. That doesn't change anything. I draw these two branches together instead of one here and the other one there. I brought them together. It doesn't change anything, right? So redraw this, and it is this. So I don't want this. You see, I have a battery here and a battery here. Do you see that these two batteries are in parallel? Well, you say, no, not exactly. There is a resistor here. How can I say the batteries are in parallel? Well, let's consider this way. Let's consider this 3,000 is not a real resistor. The 3,000 is the internal resistance of a battery. You know that a real battery has internal resistance. An ideal battery has no internal resistance. So this is a real battery. And this is another real battery. These two real batteries are identical, and they are connected in parallel. When two batteries are connected in parallel, what is the equivalent voltage? It's the same voltage as the individual one. So these two batteries connected in parallel is equivalent to one single battery. Still 3.3 volts. These two batteries combined in parallel is equivalent to a single battery 3.3 volt. How about the internal resistor? Look, the internal resistors, these two internal resistors are also in parallel. When two resistors are in parallel, their value, their equivalent value becomes half as much. Therefore, my combined single battery has an internal resistance only half that much. So I need to show the internal resistance now. That is my equivalent single battery. Then these two batteries in parallel is equivalent to this, and this is connected in parallel with 4700 ohm. Now this circuit is so simple. Do you need Kirchhoff's laws? No. Just Ohm's law is okay. What is the current in this resistor? Ohm's law. This resistor and this resistor are effectively in series. So you add them together. So it's 3.3 divided by the combined resistor, which is 6200 ohm. And take a calculator and do the division, you get the answer. What is the result if you do the division? Alright, I have kept all the decimals from the calculator. Okay, so this is amperes, okay? Because you have ohms here and volts here, so the unit is amperes. So this value is the current here. Of course, the current here is also this. But this is not my initial circuit. My initial circuit is here. So what is the current here and here? Look, this current here is supplied by the two batteries. So each battery supply how much current? Half of this. Therefore, the other current is just half of this. So it's 0.000. So take a calculator, divide by 2. So if I call this whatever, I think, so it should be this, I3, and this should be I2, and this is I1. So I3 is this, and I1, and I2. I1 and I2 is just half of this, all right. I have kept all the decimals there. In fact, you don't need to. So how many decimals are there? It's just two significant figures, okay. So you can keep two significant figures and round it up to 7. Yeah. So these are the answers. And that is, this question is so interesting that I like to show you as an example. Instead of doing Kirchhoff's law, you just do Ohm's law. You got it? Thank you for watching. See you next time.